É um objetivo do AMS. O espectrómetro magnético alfa está há um ano, fez agora, acoplado à Estação Espacial Internacional. Na reportagem seguinte vamos perceber como funciona este que é o maior equipamento científico na Estação Espacial.
Em maio de 2011, pouco antes da retirada da frota de vai-vens, a NASA decidiu um voo adicional para transportar um detector de partículas com 8 toneladas. Missão: responder à pergunta fundamental: de que é feito o universo? O AMS, ou espectrómetro magnético alfa, a que já chamam também o telescópio Hubble para raios cósmicos, começou logo a recolher e analisar milhões de partículas de alta energia provenientes das mais remotas partes do universo. Esses raios cósmicos primitivos, detectados acima da atmosfera terrestre, podem conduzir a uma nova física. O AMS é totalmente controlado a partir de um centro de controlo no Laboratório Europeu de Física Nuclear, o CERN, perto de Genebra. Equipas internacionais ocupam-se do fluxo de dados 24 horas por dia, 365 dias por ano.
E esta reportagem que acabamos de ver é uma boa deixa para avançarmos para a conversa com os meus convidados de hoje, Igor e Grichka Bogdanov. Estes dois irmãos, Igor é doutorado em Física Teórica e é professor catedrático de Cosmologia na Universidade Megatrend de Ciências Aplicadas de Belgrado, a capital da Sérvia, tal de resto como Grichka, mas este é doutorado em Matemática. Thanks for being with us today. You are cosmology professors in a field where there is so much to be known yet. What are you teaching your students?
We are mainly teaching what happened, what occurred at this very mysterious instant that is called the Planck's time. You know, Planck's time is a very tiny fraction of time which is representing 10 power minus 33 seconds after the zero, which means after the creation, so, or the absolute beginning of the universe. You know, we are exploring, Grichka and myself, through mathematical tools, through mathematical ways, what may have occurred between the Planck's time, which is the moment when the Big Bang occurred, and all the scientists agree on the fact that sometime over 13 billion years ago, this Big Bang event occurred. But, you know, we decided, Grichka and I, when we entered in our doctorate PhD studies, to explore what may have happened beyond the Planck scale and beyond the Planck's time. And we discovered some very, very interesting things, which we are not teaching these things. These things are part of our research, but we are teaching, to answer your question, what happened at the Big Bang moment and beyond.
Before starting this conversation, our audience could see a story about AMS, the Alpha Magnetic Spectrometer, which was launched about 1 year ago to observe antimatter and dark matter. I've been reading your book, La Visage de Dieu, A Face de Deus, and in Portuguese, of course, and in chapter 20 we can read, where does dark energy come from? So this is the question for you now. Where does it come from?
That's a very interesting question. I think we may have some little beginning of answers.
It is, of course, a mystery, part of the surrounding mysteries about the universe and all the hidden part of this universe, of course. But what is very interesting in this question of dark matter is that it is deeply connected with the very, very beginning of the universe. In fact, and indeed, during the courses of our PhD studies, in 1994, we discovered through the equation, which is part of the, let's say, wonder of the thing, through the equation, we discovered the existence of a mysterious field. This field, so-called field, was totally unknown at that moment, but we discovered that its main property was to accelerate the expansion of space-time, which is something, or at that moment, was something quite unexpected. And when we defended our thesis in 1999, it was a sort of shock for the jury, for the audience even, and they didn't believe in the existence of this so-called accelerating field. But it was coming out of the equation. So we had to convince the audience or convince our colleagues of the existence of this so-called field. But 2 years after, somewhere in 2000, 2001, came the first observation of the light coming from distant stars called supernova. And it was a proof that the universe was constrained by a force bringing a sort of acceleration. And this acceleration now, or this field, is called black energy, dark energy, and it is a sort of, let's say, unknown, unpredictable to any kind of known phenomenon field, a scalar field, which is the regular name in science now, a scalar field. But this scalar field, the question that you raised is, where does it come from? And the answer is, it comes, so it is what we think through our researches, but we think and presume that it comes from before the Big Bang. Before the Big Bang. It is a sort of trace of a very strange phenomenon which occurred before the Big Bang, let's say beyond the Planck's wall, and this strange phenomenon was the source of a tremendous, let's say, fluctuation of reality, and specifically time and space at that scale, up to zero. So the source of all those incredible phenomena, the source has to be identified with zero. And what is zero? It is the initial singularity of space-time. So that is part of the mystery, but the mystery now is, let's say, surrounded by a sort of glimpse of light.
So this means that something was there before the Big Bang.
Yeah, but this something, between quotation marks, before the Big Bang is not physical. The Big Bang is physical. It is totally connected with the energy, the tremendous energy of the Big Bang, which, as the universe expanded, and we know that it was expanding extremely rapidly, you know, the temperature and the energy went down. But, you know, before the Big Bang, there is no energy. It is something else. And this something else, we, Grichka and I, postulate that this is not energy, this is information. Information. You know, we live in a real time. This is the fourth dimension of our space-time metric. But when you go under the Planck's wall and you go down to zero, then after having get across a sort of fluctuation period that was quickly described by Grichka, we reach the zero initial singularity where the real time doesn't exist anymore. And it is replaced by, all physicists know this word, imaginary time.
Imaginary time is time, but measured with imaginary numbers, which is, of course, is totally different than real numbers. What is an imaginary number? It is simple for mathematicians, in fact, indeed. An imaginary number is a number whose square is always negative. For instance, 2 and the square is power 2 is plus 4. But 2i, I is the symbol of imaginary number, is equal to minus 4. So when you measure time with those strange but existing imaginary numbers, in this case, you have a line which is orthogonal to the real line of real time, but this line is imaginary time.
So this imaginary time notion is very interesting because you know, all the physicists know that real time is connected to energy. You know, it is a conjugated variable of energy. But imaginary time is connected as well to information. It is a conjugated variable of information.
I would like to know your opinion about this. What is more scientific for the scientists? What is the scientist's role? I mean, is it to research about how did this all start, or why and what for did this all start?
Good question.
That's yes, big question. In fact, the scientist has two hands, the left and the right. The left hands probably should be worried about how all this work. How is it possible, and what is the underlying mechanism explaining more or less the such phenomenon, and the laws are behind the phenomenon, etc. So this is the left side, but the right side, and the double meaning of it, of course, is to question and to address the why, because it is not the privilege of, let's say, esotericism, of religions, or, let's say, revelation, to cope with these questions. The why is very important as well. Of course, it moves another part of the mechanism of investigation. It moves imagination, it moves intuition, it moves even instinct in a way. But it is very and quite relevant for a scientist to be preoccupied, to be worried about those questions of why is it so. And even some very important major jumps in science have been brought about this attitude. Why is it so? And even when you push this why attitude up to a certain limit, you are confronted to the Planck's wall, and beyond this, to the zero instant, which is the initial singularity. And when you are in front of those major objects of knowledge, well, those questions connected to those answers and reciprocally are absolutely fundamental. It's essentially the essence of the meaning of the universe.
This could be put on another way. This is the laws of physics. Do they rule the universe, or do they explain the universe?
Well, I think both. Because, of course, they rule the reality, and the universe cannot escape the laws of nature. The universe is obliged to obey to the main laws, gravity laws, speed of light, and all these kind of fundamental constants that makes the universe having the appearance it has, and existing the way it does. However, you know, it's not only a question of obeying to these fundamental laws. There is also, I think that, you know, the universe is this aggregation of laws. It is, you know, the universe is the expression of the laws as well, you know. And that makes it, that is deeply connected, at least this is what we think, Grichka and I, with the mathematical essence of the reality.
Yes, because the thrilling part of this interrogation about the laws is where, of course, we observe the laws and we experiment the laws, and it's impossible to get out of those set of laws. But where do all those laws come from? That's the major question. Yeah. Where does it come from? Where does it come from? What is the origin of the law? And if, for instance, we observe, as we do every day, when we have the opportunity to, let's say, to investigate the mystery of the initial time, to investigate the Big Bang moment, this major instant, we observe that the laws are very precisely set up at this moment, and also that the rules and let's say the fine-tuning of these rules is absolutely compelling, extraordinary. But the question, which is immediately adjacent to this observation, is, well, we observed a wonderful fine-tuning, for instance, at the very moment of the Big Bang, but where does it come from? What is the origin of, for instance, the number pi? Pi is a very usual number, 3 and 1, 4, etc., etc. But where does it come from? Because if pi wouldn't have been exactly to the billionth and billionth decimals exactly written as it is, nothing in the universe could have existed. Nothing. So pi was definitely was absolutely there before the Big Bang. Before. At the vicinity of the initial singularity, when I evoke this term, pi was already there. Where does it come from? That's part of wonder in the universe, in fact. It is preposterous to imagine to bring the complete answer to this question, but the fact to raise the question in itself already is a wonderful progress for human mind.
You work together. Do you always agree with each other?
Yes. We always agree, and when there is a beginning of a disagreement, it is for better understanding. you know, so.
And reducible.
Yeah.
You are here to participate on the Yoga Day. What does this have to do with yoga?
In fact, we are here at the very kind invitation of the great master of these ashrams in this magnificent country that we have the pleasure to discover today. We are convinced, and that's the reason why we answered positively, of course, to this very kind invitation, that there is a connection between science, rational approaches of surrounding mysteries of the universe, and yoga, which is another way to approach exactly the same reality. Reality has, exactly as we can evoke the fact that a sphere has two poles, the north and the south pole. In fact, if we, let's say, invoke the idea that science is the north pole, undoubtedly yoga is the south pole of the same sphere. It is another attitude. And we are very curious to know exactly what is behind or what is beyond what we know about yoga. We are not practitioners of yoga, but we have, by intuition, the certainty that it is a magnificent way to cope with the same part of mystery surrounding our universe, but also ourselves, because we are part of the universe, and we are the universe in a way.
Yeah, well, just to complete his metaphor of the sphere with the two poles, let's imagine, for instance, a mountain. And let's imagine that we have both ways to get to summit of the mountain, the north and the south way. You know, let's imagine that the north way is the scientific way and the south way is the yoga way. But, you know, we climb the same mountain. Both ways are very different to explore, very different to experiment everything. But, you know, you get together at the summit of the mountain.
Yes, but yeah, maybe the scientist is a little bit, let's say, late. And when he is at last, after some huge efforts, he hit the summit. Already, the yogi is there, and
there.
Very peacefully is, at last, you are there. And of course, he welcomes you.
Grichka, Igor, it was a great pleasure for us to have you here in Consciência. Thank you very much.
Yes, thank you very much.
E como já ficaram então a saber, os irmãos Igor e Grichka Bogdanov estiveram em Portugal para participar nas comemorações do Dia Mundial do Yoga. As comemorações são organizadas pela Confederação Portuguesa do Yoga, alternadamente em Lisboa e noutra cidade. Este ano foi em Beja.
A ideia de celebrar um Dia Mundial do Yoga nasceu em Portugal em 2001. Foi lançada por Jorge Veiga e Castro, um engenheiro que há mais de 40 anos pratica yoga e se tornou já uma referência mundial para os praticantes desta filosofia.
O yoga é uma filosofia de vida e muitos a procuram para criar novas competências físicas, emocionais, mentais, trabalhar com mais energia, combater o stress. Portanto, pessoas de todos os quadrantes procuram o yoga. Esta mensagem é uma mensagem que parecendo utópica, não é, porque, como disse há pouco, toda a gente quer paz, não há ninguém que não queira. Eu tenho corrido o mundo há 10 anos, nunca encontrei uma única pessoa que defendesse a guerra, nunca encontrei nenhum fundamentalismo que estivesse acima da estabilidade, da paz e do amor. Então é fácil, começámos pelos praticantes de yoga, depois começámos a conversar com os políticos, tanto na Unesco como no Parlamento Europeu e no nosso Parlamento também, depois vieram os cientistas, depois veio todas as pessoas que têm bom senso, juntaram-se a este movimento que hoje é apoiado pela, obviamente, além da Índia, que o proclamou já numa cimeira em 2011 em Bengaluru, no final de 2011, os Estados Unidos. Hoje temos cá, além destes dois grandes países, a Espanha, a França, a Itália, o Canadá, o Dubai, etc. Muitos países estão aqui representados a dizer estamos com esta iniciativa.
A Confederação Portuguesa do Yoga preparou um programa de comemorações mais vasto do que apenas as tradicionais aulas ao ar livre. No dia 23 até houve teatro e numa conferência da Arshana, mais de 25 oradores, uns praticantes, outros simpatizantes, partilharam apelos a uma sociedade mais fraterna, mas também experiências e dados científicos sobre as vantagens da prática do yoga, que para os organizadores não é incompatível com qualquer religião nem com a ciência.
A principal mensagem do yoga é um desenvolvimento total e exponencial do ser humano, não só fisicamente, mas também através de um controle emocional, de uma aquisição de maior energia, mas principalmente do controle mental. Então não há nenhum choque entre os praticantes de yoga e os cientistas, pelo contrário, há muitos cientistas que praticam yoga e obtêm resultados muito maiores do que o que tinham antes, como também há muitos místicos que praticam yoga e se aproximam mais de Deus, etc.
Esta edição do Consciência fica assim completa. Nós estamos por aí, pela internet e pelas redes sociais, onde também nos podem encontrar, ou então aqui na televisão, de hoje a uma semana. Até 2 dias.